Okay, so today we are just practicing what we were working on yesterday, not teaching anything new. We have a few examples left on this handout. We may not do all of them. We'll just kind of see how we're doing. We talked about finding maximums and minimums yesterday, and we said we had to find our critical numbers first. What are critical numbers? Those are the places where we could have a maximum or minimum. How did we find them? Where the derivative is what? 0 or undefined. All right, what should I do before trying to do the derivative of this? So 3/5 times 30. 30 divided by 5 is 6, times 3 is 18x minus 3/5 x squared. So to get our critical points, we do the derivative. Derivative of 18x is 18 minus 2 times 3/5 is 6/5 x. So I'm going to set that equal to 0. How could I get rid of my 6/5? We multiply by 5 over 6. 18 divided by 6 is 3, times 5 is 15. All right, critical points are where my derivative was 0, so that was 15, or where it was undefined. Is this ever undefined? No, because I didn't have x on the bottom. Now, if it had been like 6 over 5x, what would I have to add? What would make 6 divided by 5x undefined? 0. If you have a fraction, we know the bottom can't be 0. So that would add a critical point. I'm looking on the interval 0 to 30. So to find my maximums or minimums at this point, we had to plug in the endpoints and our critical points to the original function. So when we do that, if we put in a 0 to the original, what do we get out? 0. If we plug in 15, okay, 3/5 times 15. So 15 divided by 5 is 3, times 3 is 9. Times 30 minus 15 is 15. So we get 135. If we plug in a 30, what do we get? We have 3/5 times 30 times 30 minus 30 is 0. And anything times 0 is 0. So then, how do we find our max and min? The biggest number, that's my max. Smallest is my min. Since these are the same number, we actually have 2 of them. Questions? Let's go ahead and do example 7 for sure. So I'm asking you to find your critical numbers. I didn't even ask for the max and min this time. I only asked for the critical numbers. Critical numbers are anywhere this is 0 or undefined. So what do we have to do? Derivative. So that's low. So we have to do quotient rule. D high, derivative of 3p squared, 6p, minus high, d low, derivative of p squared minus 4 is 2p, over low squared. So on the top, that gives me 6p to the third minus 24p minus 6p to the third over p squared minus 4 squared. Those cancel, so we get negative 24p over p squared minus 4 squared. Critical points. Anywhere this is 0 or undefined. So, if I want to know when this equals 0, you would multiply over the denominator and you just get negative 24p equals 0, which gives us 0. Where would this be undefined? When the denominator is 0. So square root plus and minus, so p is positive or negative 2. So I got 3 critical points this time. 0, 2, and negative 2. So remember, you have to find when the derivative is 0 or undefined. You need to check both. Questions there? We can't do the max and min on this one because I didn't give us an interval to check. I'd like to do, let's do either example 9 or 10. Which one you want to do? 9? All right. So this time I'm asking you to find the maxes and mins. So we have to find critical points, and then we have to test them. So we need our derivative. So 5 times 2/3 would be 10/3 x. What's 2/3 minus 1? 2 over 3 minus 3 over 3 is 1 over 3. Minus 5/3 x. 5 over 3 minus 3 over 3. All right. How about, let's factor out. What's our greatest common factor? So looking at the numbers, 10/3 and 5/3, we could take out 5/3. With your variable, you take out the smaller exponent, so that would be negative 1/3. All right. 10/3 divided by 5/3 would be 2, and we took out all of those x's. Minus, we took out the 5/3. When you factor out, it's like subtracting exponents. So 2/3 minus negative 1/3 be 2/3 plus 1/3, which is just an x to the first. I need to know when that is 0. You can also rewrite this, and negative 1/3 is just a cube root on the bottom. So what makes this equal 0? What happens when x is 0?
0 undefined.
It's undefined. So that is a critical point because it's undefined there. And then to make it equal 0, if you just set 2 minus x equal to 0, you get 2. So our critical points are 0 and 2. What happens if, like, I had gotten a critical point of 5? Would I use it here? No, because I'm only looking between 1 and 4. So now I need to test my endpoints and my critical points. So I need to do negative 1, 0, 2, and 4. These are not going to be all nice, pretty numbers. So you can grab a calculator if you want. A couple of them work out nice. If we put in a -1, what does -1 give us?
6.
And 0? 2? And 4?
2.51985.
So 2.52. So what's my max?
Oh, shoot.
Yeah, that first endpoint. And our min is at 0. All right, so do you guys think you could handle finding maxes and mins? So what I have for you is a handout. It's got 10 questions, finding maxes and mins. Most of them are nice, pretty polynomials. The last 3 are not, so those last 3 are the ones where you're going to have to watch for something to be undefined. Your polynomials, are polynomials ever going to be undefined when you do your derivative?